We originally wanted to design a travel mug that was safer to drive with, and in addition to this, reduce the risk of spills and burns.
Our group debated on a lot of aspects of the final design of the cup, including the body, the lid, and additional features like the insulation. The cup needed to be small enough so it wouldn't obscure the user's view. It needed to have a lid that was spill-proof in order to prevent burns to the user while driving. Finally, our cup needed to be able to hold beverages at a drinkable temperature for extended periods of time.
Our team bounced around ideas on how to prevent burns, and we thought of using temperature indicators and temperature probes, but they were genuinely too complicated, like the ones on the Starbucks Amber, and we thought about drawing the liquid through some kind of heat sink like they use in computers, but it made it way too complicated and fragile.
Finally, our team came across phase-changing insulation, which, unlike traditional insulation, would take up more volume in our product. A competing product, the Stanley Quick-Sip, took up about 6.5 ounces of their total volume. So to include the average serving size of coffee, which is about 16 ounces in the US, we'd have to increase the size of our product significantly.
Since the radius of the outside of the cup couldn't be expanded, it had to fit inside of cup holders, so we'd have to have it expand upwards. However, to fit that amount of fluid, the size of the cup started to get a little bit out of hand.
In order to minimize the size of the cup, we decided to make a chamber at the bottom, a reservoir sort of, that would be filled with our PCM, or phase-changing material. This means that as the user would drink through the straw, the user would draw liquid through that reservoir before drinking it in order to cool it down to a drinkable temperature.
The phase change technology works similar to an ice cube. At first, it melts itself and cools down the liquid, absorbing heat into itself, making the liquid cool much faster. But once it reaches the same temperature, it starts to re-solidify, and this makes the liquid cool down much faster. But with phase change, when the liquid reaches the temperature of the insulation, it starts re-solidifying and releasing heat back into the beverage, keeping it hotter for longer. Our final design focused on functionality. We didn't want to sacrifice performance for appearance, so we chose a more rugged style while finalizing our design. The cup uses 18/8 stainless steel, insulated with a vacuum seal insulation and a radiant heat barrier. It provides the best ideal insulation for the cup. Our phase changing insulation is lined on the inner walls. In case of damage to the cup, the phase change insulation is 100% biodegradable, safe to consume, and renewable, just to make it as safe as possible.
We had a few issues with the original prototype. Because we used the body of our prototype as a Stanley mug, we wanted the threads to completely line up, which meant we decided to mold and cast the interior of the lid so that the threads would work. Unfortunately, we had 2 molds that did not make it to the final stage, including 2 blowing up, and our last one that did shrank so much that it didn't fit at all with our mug. We ended up 3D printing our own lid, which actually works a lot better, and the only issue with that is that it's not entirely safe to drink from as of right now.
One of the major problems we had with the prototype was when we went to go test our prototype, there was a drop test that we were supposed to do where we drop it and see how well it stood up, but the epoxy that we used to seal around the edges of the prototype, it made the prototype very brittle, so it would break and make all of the results invalid. And besides that, it was mostly just the wax was difficult to work with. It was really hard to clean up, it took a lot of elbow grease, and the straw could have been designed a bit better, but besides those things, it was mostly minor, just small problems with creating the design. And the straw could have kind of been designed better, but besides that, it was mostly minor things of having to cut it and just things that could have been fixed with minor changes in the design. Although our prototype isn't the best and most well made, it does demonstrate that the design idea is viable, and we hope you liked it, and we hope you liked our presentation. Thank you for your time.